Section 7.4, Percents and Interest. A definition of percent, n percent, is n over 100, where n is a non-negative number. So if we're converting from percent to fraction, all we're going to do is put the percent number over 100 and reduce. So if I want to convert 25% to a fraction, I would put 25 over 100 and then reduce to 1/4. Converting from percent to decimal, we're first going to change it to a fraction. So we're going to divide the percent number by 100, just like we did before. And then when we're doing that, then the decimal moves to the left twice. So technically what we're doing is 38 over 100, which changes to 0.38. Or you could just say 38, move the decimal twice, and we get 0.38. Converting from a decimal to a percent, you end up multiplying the decimal by 100, which is the same as moving the decimal point 2 to the right. So 0.063 moves twice this way. That would be 6.3%. If we're doing 0.3 repeating, move it this way twice. That would be 33.3 repeating percent, which is also equal to 33 1/3%. Okay, remember 3 is the repetend, so we put it over 9 and reduce. That would be 1/3. Make sure to look at how it's asking for the answer. Converting from a fraction to a percent. Okay, first change it to a decimal, and then we're going to change that decimal to a percent. So here we'll do 3 divided by 4 is 0.75, and then we move it twice, so 75%. Here, 1 divided by 9 is 0.1 repeating. We move it twice, so it becomes 11.1 repeating percent, or 11 1/9%. Applications involving percents. First, we're going to look at some application problems, and all we're going to do is put it directly from your sentence into an equation. So some keywords to look for: of means multiply, is means equals. And you may have in the past used the is over of equals percent over 100. And you can use this if you want. I am not, because it does not work for every problem. So you can use it if you want, but just know that it will not work for every problem, so sometimes you may have to use my way. So when you're doing these, we're going to change all percents to decimals. When you use the is over of equals percent over 100, you don't have to do that. So the first one, we're going to find a percent of a number. What is 20% of 60? So I'm going to put this directly from this sentence into an equation. What is x? Is equals 20% will be 0.20. Of means multiply 60. So this one, all we have to do is put in our calculator 0.20 of 0.2 times 60, and we get an answer of 12. Now we're going to find a percent of one number. Find what percent of one number is another. So again, 6 is what percent. I usually use p, and that reminds me to change it to a percent later. Of means multiply 24. Normally we would write p times 24 as 24p. So I'll divide by 24, and p is going to be 0.25. And because it's p, that reminds me I need to move that 2 to the right to get 25%. Okay, now we're going to find the number when the percent of the number is known. So 17 is 30%, 0.30 of multiply what number? We divide by 0.30. X equals 56.6 repeating. 0.6 repeating, remember, was 2/3. Or we could have it change it to improper fraction, 170/3. So this is 3 different ways to put the answer, so you need to make sure you look for what MyMathLab wants you to have the answer in terms of. Okay, so on these problems, you don't always have to set up an equation. Sometimes you could just multiply or divide numbers and figure it out, and that's perfectly fine. Okay, so we've practiced a little on how to convert a sentence into an equation. Now we're going to look at some actual application problems. A house that sells for $92,000 requires a 20% down payment. What is the amount of the down payment? So this is down payment is 20% of $92,000. So our down payment is 20% of $92,000. Or you may have just written 0.2 times 92,000 without the DP equals, and that's perfectly fine. We get $18,400. If Alberto has 45 correct answers on an 80-question test, what percent of his answers were correct? Okay, we can set up an equation for this one, but it's probably easier just to say, well, he got 45 correct out of 80. That's 0.5625. Move the decimal. So he got 56.25%, or 56.25 is 1/4. Again, make sure you look at what MyMathLab wants you to have as the answer. Okay, the next 2 examples are very similar to each other. Okay, Annie's meal at a restaurant costs $23.10. If she wants to leave a 20% tip, how much will the final check be? So what we could do is take total cost times the percentage, so it'll be 0.20 times $23.10, and we get $4.62. Now remember, this is the tip. Okay, so we want to know how much the final check will be. We've got to take $23.10 and add the tip to it. So then the final cost will be $27.72. Okay, the next one is a similar problem, except this time, instead of increasing the cost, because here we had to add the tip, here we have a discount. A bookstore is offering a 5% discount. If a book originally cost $12, how much will it be after the discount? So we're going to take our 5%, multiply it times the cost of the book. That'll give me 0.60, so 60 cents is the discount. And this time, since it's a discount instead of something that we're adding to it, we're going to subtract. And we get $11.40. Okay, the next 2 are similar. We're going to be looking for the original cost. Okay, so Kelly bought a bike and a year later sold it for 20% less than what she paid for it. If she sold for $144, what did she pay for it? Okay, there's 2 ways to work this problem. I'm going to show you both ways. Okay, we can think of it as original price minus 20% of the original price equals the new price. Okay, well, we don't know what the original price is, so I'm going to call that X minus 20% would be 0.2 of the original cost, so of x, is 144. So treat this as a 1x, so 1x minus 0.2x will be 0.8x. Then divide by 0.8, and we get that it originally cost $180. Okay, so another way to look at this is if we're taking off 20%, 100 minus 20 is 80%, so we're left with 80%. So then the new price is 80% of the original. The new price is 144.8 of the original, so of means times. And notice this is the same equation we have here, and so we're still going to get 180. You could do it this way also. Okay, so this was marked down. The next one is going to be an increase. So it's similar, except now Keith is getting a raise. If his salary is now $72,900, what was his salary before? So again, I'm going to do it both ways. We're going to have his original salary plus his 8% raise equals his new salary. So his original salary is X plus 0.08 times X, because it's 8% of his original salary, is 72,900. Treat this as a 1x. 1 plus 0.08 will be 1.08. Divide by 1.08, you get 67,500. Okay, so this other way of doing it is we had 100% of his salary, we added 8 more percent, now at 108%. So you'd go 1.08, changing that, of the original salary is now 72,900. That would be that same line right there. Computing interest. So principal P is the original amount of money deposited or borrowed. Interest is I. It's the amount of money the bank will pay for using your money, or the amount you paid using the bank's money. Interest rate, R, is the percent used to determine the interest. And then simple interest is interest computed on the original principal. So I equals PRT, where time is in years. So interest equals principal times rate times time. Now, these formulas for the rest of this section will be given to you. You just need to know which one to use. Okay, so all we're doing is finding the interest. We're going to use this formula, I equals PRT. So we're going to find the interest. That tells us we're looking for I. If $3,000 is deposited at 3.5% for 3 years, and then what about for just 9 months? Okay, so let's first see. 3,000 is P, that's the amount we're depositing. This is R, which is 3.5%. And if we move to decimal place, 0.035. And then time in years. So I equals PRT. So I equals 3,000 times R, 0.035, times T, which is 3. Put all of that into your calculator, and you will find that the interest is $315. Now, if it's for 9 months, remember that T is measured in years, so this is going to be 9 out of 12, or 9/12. You can reduce that if you want, but we're going to be putting it into this equation. So I would be P is 3,000, R is still 0.035, and time is 9/12. And we get $78.75. Now notice I wrote the formula for both of these. I want you to do that so that I could see what formula you're using, and then I will look to see that you plugged it in correctly, and then your final answer. So if you just give me a final answer, it's right or wrong, but if you show me the formula you used and it's correct, and then you plugged in the numbers correct, I could give partial credit. Okay, the next is the amount or balance after time t. So this right here is just showing how the formula comes up. A equals principal plus interest. So you take your interest and add it to the principal. Right here, it's showing PRT. That's what interest is. And then factoring out the P. So the formula I'll give you will look like this. A equals P parentheses 1 plus RT. Okay, so if a student takes out a loan for $700 at an interest rate of 9%, how much will the student owe in 10 years? So I like to label everything. So $700 is how much he's taking out. That's the original principal. The interest rate is R, 9%, and then 10 years is T. So I want to know how much the student owes. That's knowing A instead of the interest. I write out my formula, and then I start filling in. P is 700, parentheses 1 plus 0.09 for 9% times 10. Okay, so if you put all this in your calculator exactly as I've written it, you'll get $1,330. The next one, how much money should be deposited now at 2.25% interest in order to have $10,000 in 5 years? So here, R is 2.25%. T is 5 years, and then the 10,000 we have to determine whether that's how much we're depositing or how much we want to have in the future. And here, this is what we want in 5 years, so that's A. So A equals P1 plus RT. So I'm going to plug in 10,000 for A equals P1 plus, move this twice this way, 0.025 times 5. To solve for P, I'm going to divide by everything in the parentheses. Notice that I'm not putting it into my calculator yet. I don't put it into my calculator until I'm ready to get my final answer. The reason for this is that if you put it into the calculator and round, you will get a slightly incorrect answer. So in your calculator, you'll type 10,000 divide parentheses 1 plus 0.025 times 5. When you do that, you'll find that the principal is $8,988.76. Now I rounded to 2 decimal places because money has 2 decimal places. Compound interest is earned on previous interest as well as the principal. So instead of just earning interest on the principal, you're earning money on past interest that you have accumulated. Okay, so when you want to use this formula, is you're going to see the word compounded in there. If you see the word compounded, then you're going to use this formula. So suppose $1,000 is deposited into a savings account that pays 6% annual interest compounded quarterly. So there's your compounded. What is the balance after 2 years? So $1,000 is deposited, so that's our principal, and 6% interest rate, and 2 years. Now, we also have an N in this formula, and that's the number of times it's compounded per year. So here it says quarterly, so N is going to be 4. If it said twice a year, then N would be 2. If it says monthly, N would be 12, and so on. Okay, so I'm going to first write my formula. So A equals 1,000. 1 plus 0.06 over 4 to the 4 times 2. Now this is the only time I say go ahead and multiply something in the calculator, and that's go ahead and get this exponent. 4 times 2 is 8. So then type in 1,000, open parentheses, 1 plus 0.06 divided by 4, close parentheses, to the 8th power. And you should get $1,126.49. And the last problem, how much money should be deposited now at 4% annual interest compounded monthly in order to have $600 in 5 years? Because again, there's that word compounded. So that immediately tells us we're going to use this formula. Okay, so we're going to go through, deposit there's our interest rate, there's our time, it says monthly, so that's N is 12. We just got to determine is 600 the principal or amount in 5 years. It says we want 600 in 5 years, so that's A. So it's going to be 600 equals, we don't know P, 1 plus 0.04 over 12 to the 12 times 5. Remember, go ahead and do 12 times 5, that's 60. And just like we did before, we don't want to put this in our calculator until we're ready to get our final answer. So we divide by the parentheses with the power. Okay, so in your calculator, you go 600 divide parentheses 1 plus 0.04 divided by 12 raised to the 60th power. And you'll get $491.40. This concludes section 7.4. If you have any questions, please feel free to use the Ask My Instructor button.